Alright guys, so at this point we have gone over graphing lines in class and in some worksheets and in 3 videos, and those 3 videos so far have shown us those 3 ways to graph lines. Using a table of values. A table of values is especially useful when we have our equation where it's set up with y equals, because then it's really easy for us to type into our calculators and get the table out. So we're not even doing the plugging in ourselves. X and Y intercepts, which are the easiest method when we have our equation in standard form, and when these coefficients A and B divide evenly into that constant C. If they don't, then we were kind of SOL again. We also have our slope and intercept form, which was that y is equal to mx plus b that we played around last class. I played around with on Friday and on Wednesday if you were fast with those worksheets. So the only one of these we haven't truly discussed or haven't given you a video for is the fact that we can also do this using a slope endpoint. We don't need that point to be the y-intercept. Any point will do. If we have a point, we can use the slope to move around on the graph. So that's a method that would be particularly useful for this example over here on the right. We have our slope of 2/3, and we have our intercept, right, of 5/3, which tells us that our line goes through the point 0, 5/3. Now, it is not smart to be using this fraction as a place to graph. We're not going to necessarily hit any of the true points on the line if we are guessing at where this fraction actually is, especially a fraction like this, which has a repeating decimal. So it is not in our best interest to try to graph 2.666666 on our graph. So this is one where on a test, I would expect you to figure out a point on this line that works better than this. So the easiest thing to do would be to go ahead and type this into your calculator and then find the first point that doesn't involve a fraction or a decimal. That would be the best thing to do. So you'd go to your table and your calculator and you type this in and see what happens. I don't have the calculator handy. It's somewhere across the room, and I can't show it to you anyways because I'm stuck using this. So what I'm going to do is I'm going to try to be clever about what I plug in and sort of talk to you about how I would do that. So I want to be able to plug in some x here such that this thing makes a nice pretty whole number. Obviously 0 was a bad choice. I do actually want to keep the fraction here because I want to be able to add these pieces together, right, and get a nice whole number. And so I could try another number just to see what's happening. It's probably what I would recommend a student do. So if you tried 1, get y is equal to 2/3 times 1 plus 5/3, which is just 2/3 plus 5/3. And nope, didn't work. So ideally what we really want to happen here is we're going to end up with 2x over 3 plus 5 over 3. We want 2x plus 5 to end up being a nice pretty number that's divisible by 3. And it just so happens that if we use 2 here, it's going to work perfectly. Again, though, you could have just guessed and checked, or ideally just use the table. But if we use x is equal to 2, we multiply 2 with that 2/3. We're going to get 4/3 plus 5/3, which is 9/3, which is 3. Hooray! We found a nice actual point on our line. We can keep the other points that we found. They are not terrible. We still have our intercept that we can play around with. We also have this point we found here of 1, 7/3. So we can use those points also to check that we're on the right track when we go to graph ours. But we definitely wanted that nice pretty whole number point. So 2 and 3. So right now I'm going to use this point that we found, 2, 3. It has nothing to do with the slope. It is just a coincidence that the slope is similar. And I'm going to go put that point on my graph. And now that I have that point on my graph, I'm going to use my slope to move around. So our slope is 2 over 3, which means that we are going to go up 2, and then we are going to go right 3. Again, it's up to us. We could also think of this as -2 over -3. So if we wanted to do it that way, we could go down 2, and then we would also go left 3. Making sure that our rise goes up if it's positive, down if it's negative, and our run goes right if it's positive, left if it's negative. So let's do the top one first. So first thing we're going to do is go up 2, 1, and 2, right? So there's our up 2. And then we're going to go right 3. 1, 2, 3. There's our actual point. We'll keep doing that. Up 2. And then right 3. Ignore that my spacing is getting larger. And then we'll do it in the other direction using this piece right here. Down 2, and then right 3. And down 2, and then right 3. Again, my spacing got way bigger there for some reason. I just can't keep my stuff straight without having a grid, which I should probably just put a grid on my notes next time. And then we connect them all with a line, putting our arrows at the ends to say it keeps going forever and ever and ever. And then we can double check that it sort of makes sense with our other points that we had. The easiest one here to check is our intercept, right? So the intercept said it was going to be 0, 5 over 3. So that's right around 0 and 1.66666. I might have said 2 earlier, but it's 1.66666. And we can see we're right about 1.5. So given that I didn't actually go through this point here, and if I had, it would have been higher. Looks pretty dang good. All right, so that's a little overview of graphing lines. I'll give you one more example to try on your own. So feel free to pause the video after I write this down and give it a try. All right, so take a moment, try this one out. Pause now. All right, so what you would notice as you looked at this one is it set up what looks like our slope-intercept form, but we have x equals instead of y equals. So we're getting in some trouble here. This is still 1. We have lots of options. We could do the table. If we're going to use the table, though, we can't really use the calculator unless we take the table and reverse it. We're going to get in some trouble unless we solve for that y first. But since it's set up with a nice x equals, we could just go ahead and plug in values of y if we want. Very easy for us to get out x's with the way this is set up. So we plugged in 0, we'd have x is equal to 2 times 0 plus 3. X is equal to 3. Okay, cool. And we can plug in 1. Excellent. And so we could do that again and again and again and make a table. That's one option. Table is still available to us. What else could we do? Well, we could still do our intercepts, I guess. It's not in the right form for intercepts, so it might be nice if we wanted to do intercepts. If we went ahead and tried to make this look like our standard form, to have this look like ax plus by is equal to c, that would be ideal. So if we wanted to do that, we would want to take this 2y and subtract. So that way our x and y are on the same side together. Issue here with our slope, with the standard form, is that when we go to do our thing where we kind of like ignore the, to find our intercepts and we ignore our y, we find our first intercept. Sure enough, x is 3 when y is 0. Same thing we found over here. But what's going to happen is that when you do the same thing, when you try to ignore the x piece and look at the y, our y is going to end up being some nasty fraction. And so we kind of fail again. This is not going to be the best way to do this. Anytime your intercepts don't divide out evenly perfectly, like I said, this 2 does not go into that 3. That's when we're getting in trouble. So this is not the best way to go. Okay, well, we could also use our slope-intercept, right? Or at least if we wanted to type this into a table in our calculator, we need a y equals. So we could definitely do some of that. We could subtract that 3, trying to isolate our y term. So you have x minus 3 is equal to 2 over y. We get rid of that spouse. And so we end up getting that y is equal to 1/2 x, right? X divided by 2 is the same thing as 1/2 times x minus 3 over 2. We can split this into 2. Both pieces are being divided by 2. So we kind of know we have our slope now. It's 1/2. This is why, again, we could see this plus 1, plus 1. Our change in y is plus 1, while our change in x's is plus 2 over here. So the next x, if we had finished up this table and kept playing with this pattern, would have been 7. And we could keep going and going. But again, here, we're going to get a little bit stuck because we don't have a nice, pretty intercept, right? But again, if you've done any of the other work with this, or even if you hadn't, what you're going to do is you're just going to choose a number, try plugging it in. 1/2 is really nice. Any numbers we choose, we chose x equal to 1, we're going to end up with something that works out really nicely. Because 1/2, all we need is an odd number, so that we keep that 1/2 there, and this is going to work out. So the numerator is even. So we get y is equal to 1/2 minus 3/2, which means y is equal to negative 2 over 2, which is negative 1. So we got a point. Or we could have used the intercept, the opposite intercept, that x-intercept that we saw immediately as well. So we got a point, we got our slope, we can go ahead and graph this bad thing. Let's do it. 1, negative 1. I guess I'll add some more tick marks since I'm always so bad at my counting over. They're not even. It's terrible. Our slope is 1/2, so we're going to go down 1. Why did I say down 1? That's weird. You should ignore me. I'm going to go up 1 and right 2. And we could do that from this point. We could also just graph the points in our table if that's where we started. Any of that works. If I started here and then used my slope, I'm going to go up 1, right 2 to the next point. Up 1, right 2 to the next point. Down 1, left 2 to the next point. Again, again, again. And then you can connect all those points. So hopefully that helps you out with graphing lines. Like I said, we have lots of different options. You can always do a table. The table is pretty much foolproof. The only thing can go wrong is if you make mistakes plugging in, you can end up in trouble. But as long as you make sure that your table has at least 3 points, when you plug in those 3 points, you should see something fairly linear. And if you don't, then you know you made a mistake with one of your points and you just plug in again. You can also use your slope-intercept. That does fail you when your intercept is a fraction. And you can always use your intercepts as well. But again, if your intercepts end up being fractions, you're in trouble. So hope that helped.